All right, so I'm going to go through a quick video on how to do limiting and excess with gas laws. There's really no difference in how we approach these. You're going to do two problems. You're going to solve both of them for the same product. Whichever one gives you the smallest answer is going to be the one that's going to be the amount produced. So in our setup here, we've got our mass of iron chloride. We've got which is going to be a solid. We've got fluorine gas. It's going to produce a solid that we really don't care about because the question is not asked about it. And we've got chlorine gas. So we're given the pressure, the temperature, and the volume for our fluorine. That means we're given enough information for this element to plug into the ideal gas law to find the number of moles. We can do just traditional stoichiometry problem with the iron chloride, with the difference being that in both of these, we're going to have to do the ideal gas law for our product. We're given our volume, we're asked about the volume, but we're given our temperature and pressure. Remember, standard temperature and pressure means that our temperature is going to be 273 Kelvin, and that our pressure is going to be 1 atmosphere. So I'm going to start off with just the standard gram to mole conversion for the iron chloride to the chlorine. So we're going to start off with the 1.63 grams iron chloride. We need to convert that grams into moles. If we add it up off the periodic table, you should get 162.2 grams iron chloride. 1 mole iron chloride. Now, since we're going to the chlorine, we're going to do 2 moles of our iron chloride and 3 moles of chlorine. That's coming from our mole-to-mole conversion. Remember, this step is done in every stoichiometry problem that we do. If I stop there, I'm going to get 0.0151 moles of chlorine. Now, I'm going to stop here for right now. We could go on and plug into the ideal gas law using this information, but you'll see why I'm going to stop here in a second. So our second part is we're going to go from our fluorine to our chlorine. Now, to start this one off, we don't have grams, so we're not going to do the traditional gram-mole conversion. We are going to use the ideal gas law to convert these values and find the number of moles. So we're going to plug in and have 1.12 atmospheres. Our volume is 0.287. Now, this was given in 287 milliliters, but when you're doing the ideal gas law, it has to be in the volume of liters. We're finding moles. Because the unit of pressure is the atmosphere, we're going to use the 0.08206. Our temperatures in Celsius, that also has to be in Kelvin, so we have to turn that into 303 Kelvin. And then when we solve for this, we get 0.0129 moles of fluorine. Now, why do I know it's fluorine? Because all of these values here are associated with the fluorine. Now that we have moles of fluorine, we can go and do our mole-to-mole conversion. Again, every problem has that in it. And since we're trying to get to our chlorine, we would have 3 moles of our fluorine, and we would have 3 moles of our chlorine. And I'm going to stop, because we would need to go through and do the ideal gas law. We need to do the PV equals nRT again. But I'm going to show you how to save some time here. We now have moles of chlorine from both the iron chloride, and from the fluorine. If we go to plug these into the ideal gas law, everything would be the same except for this value here. We could either plug in we would plug into 0.0151, or we could plug into 0.0129. We already know This value, being the smallest of these two, would give us the smallest value for our volume. So I'm not going to do the ideal gas law twice. I'm only going to do it once. I'm going to use this value, which we know will give us the smallest amount, plug in. Our pressure is going to be 1.00. Our volume is what we're looking for. Our moles is 0.0129 because it's the smallest moles of these two. 0.08206 and a temperature of 273. The volume is going to be 0.289 liters. And since the question is asking for milliliters, I'm just going to change that to 289.